data is just like facts, any like raw information without like any context. It could be age, race, gender, like anything, car, book. And we said that we need to store the data in a box. The store is something that, if you can imagine, we call it a database, a place that we store the data in. And my question is, why do we need to keep the data? Yeah.
I think that we should keep the data to like keep it organized and accessible when anytime there are organization needed. For instance, let's say a hospital, of course, that keeps the name of the patient, their age, their gender, their illness, and what's going on.
Yeah. So.
And also the doctors.
Yeah. Exactly.
It helps with business decisions. Like for example, like we mentioned last class, the recommender system. So if a customer buys a product, knowing data about that customer, you can recommend other products to them.
Yeah, thanks for mentioning that. So yeah.
Oh, I wanted to see that like different so different users have different use cases. Like they may have like different business needs even for the same like data that's stored like in a database. So it's important to keep the data to like service all these different users.
Yeah.
I just have a question. When data is in a database, is it not already in a context, or is it only in a context once it's used on the user?
When it becomes information, yeah. When it puts that into a context, then we call it information. So that's the raw version. We call it just data. So back to why we need to keep the data. As your friend said, we need to keep the data because we later may need to use them like for analysis. Now in like business context, you may need it like as an organization. You may want to know your customers. You may want to see which products have like higher sales or lower, which, for example, areas, which, for example, products are more popular in, for example, specific neighborhoods. So this can help businesses to plan and hopefully increase their revenue based on the data analytics. And the other example was recommender systems, that are systems that help you find the items of your interest. And that item could be anything. Could be a movie, could be a music, could be like a computer that you want to buy, or a dress. So in many different areas, it could help. Like even for like in educational context, you may, for example, see lots of, if you are, for example, let's say, reading several papers, you see similar papers as recommendation for you. You can use it in social media, in healthcare. So it's very helpful to keep the data, especially these days with like all these advances in the technologies, with social media and with like big data around us everywhere, that we are producing data like every seconds that we are just talking here. Like with our smartwatches, when we scroll social media, when we buy something, when we literally with every step that we take, nowadays we are just generating data, and it's very helpful to keep these data somewhere, organize them, use them for example, for analytics purposes. And yeah, so this is just a quick video that I'm going to skip now, but you can watch it later at home. This gives you a very good introduction to what database, or DBMS is. And so we talked about the data. These are just some examples of the data. As you see, these are just mainly facts. Data can be in different formats. It can be in the form of the text. Like, for example, when you're writing something, when you post something on social media, it can also include image, videos. So there are different formats of the data. And database, as we mentioned, you can consider it as a place where you want to store your data. And what about DBMS? So we talked about the database, and DBMS, which stands for Database Management System. What is the difference between a database and DBMS? Anyone knows that? Yeah.
It's a storage for databases.
Yeah, that you can think of it as a storage for the databases. So can someone give me an example of a DBMS?
So database is where you store the data, and database management system would be something like a software that you use to interact with the data to retrieve or maybe change something.
Yeah, so DBMS is just a software, for example, like MySQL that help you to work with your databases. How about SQL? Is it a DBMS? Query language? Yeah, it's a query language. So SQL can be used in different DBMS, like for example, it can be used in Microsoft SQL Server Studio, it can be used in MySQL, different DBMS can use SQL, which is a query language to just query your database. Whether it's like if you want to like create a database, create tables, if you want to like update it, manipulate, like any manipulation. And we already talked about why we use databases. Yeah, here is just a very brief history of the evolution of the database systems. Back to 1960s, where we had like these file-based, and then in 70s we had hierarchical and network databases, which were just, they stored data into, like, you can think of a parent-child kind of structure, which were not very efficient, especially for like the complex relationships. That is why then later people came up with relational databases, where it could actually handle more scenarios with the data manipulation. And then we had late 90s, we had object-oriented and web-based databases. Like for example, MySQL is a web-based database, or even SQL Server. So we can actually access them also online. And did I explain this slide in this class or the other section? I'm sorry, the other section. Okay, so here is just an example of a relational database. So I do not expect you to know every detail about this right now. What I would like you to know is that to just have a general idea of what a relational database is. So in relational databases, data are stored in, for example, tables, where we keep information, like in each table, we keep information about a specific entity. And for example, an example of an entity could be a product, a customer. For example, in the context of the, let's say if you want to like build a university website, your entities could be students, right? Because you want to keep information about the students. What else? If you want to build like university website, what do you think could be possible entities? Yeah. Professors, courses, yeah, courses.
The course number.
So do we need a separate entity for a course number? And by entity, you can imagine all these entities later become your tables, right? So for example, when I say one of the entities that we want to have is courses. Why? Because we want to keep information about the courses somewhere. Let's say in a table, right? So we need an entity named, let's say, course, where we keep all the information about the courses. What information about the courses do we need? For example, course ID, course name, etc., description, and so on. We may have a separate entity for students, because we also want to keep information about the students. So what you see here are tables. So there are some steps before we reach here, and this slide is just for giving you some idea about what relational database is. And I will explain in this course how we reach to this, this step. So here you can see we have employee, manager, and department table. So we can think of it as a very simplified version of a database for, let's say, an organization, right? So for an organization, you will have some employees, right? You have some managers, and you have also like departments, different departments. And if we are keeping information about employees in the employee table, manager information in another table, and department, later we may want to see, for example, which department a specific employee is working in, right? So for example, you want to see where Manisha Shah is working in. So which department? So if we, let's say, access this database with, like, later we see, for example, select, for example, name from the employee, do we get that? Or even if you select all from the employee where the name is Manisha Shah, do you get information about which department he's working in? Or for example, what is the name of his manager? No. Who said yes? So, anyone said yes? Explain. Yeah.
If you can see you can't get the manager's name, but you can get the manager's ID, which can allow you to get the name.
Yeah. So we can get manager ID, but not the manager name. Now let's say my question is, how do we know what is the name of the manager of Manisha Shah? So we don't have that information only in the employee table. So we also need to access the manager table if we want to see the name of the manager, let's say. In that case, we need to access both databases. That later we learn we have to join these tables. And to do that, at the first step, when you're designing your database, and even before that, when you're designing your data model, when you think about the entities, you also have to think about their relationship. So all the entities in your data modeling stage will be translated to your actual tables and everything in the database, right? Let's say, for example, you have so it will be really awkward now in the recording because of my long pause. Okay, so we said, let's say you have an entity called employee. Okay, if in your data modeling you have an entity called employee, later it will be translated to a table. So this is the employee table with some columns, right? And these columns are all the attributes that you defined in your data modeling. So the data modeling stage is I can say, one of the most important part when you want to implement it, when you want to actually design and implement a database. Why? Because if you correctly identify all the entities and their attributes here, then you just have to like implement them, right? So I say, what could be like the possible features or attributes? What information do we need to keep about employees? That is the way you have to define them. You have to think, what information do I? Do I need, for example, phone number? Maybe not. Do I need, or maybe yes in some cases. But for any use case, you have to think about it. So for example, do I need to have an employee ID? Yes, for sure. Do I need to have employee name? Yes. So you have employee ID, employee name, and so on. Now, we call them the attributes of the entity employee. And these attributes will become the columns of your table later. So when you create your tables, you have employee ID here, name here, and so on. So this is what you see here. So you have a table for employee, and you need to connect these two tables or join these two tables in order to find who is the manager of a specific employee, in this example, Manisha Shah. So when you are designing your ER model or you do the data modeling, you actually have to also define the relationship between entities. And how do you do that? By thinking about possible scenarios or possible queries that the user may need, right? So you may need, for example, to find which department each, for example, employee is working in. And we don't want to put all this information in one table because that is not efficient. There will be a lot of redundant information then, right? And I will also discuss in more detail about why we actually need like this kind of a structure later. But this is just to give you an idea. When we talk about relational databases, we mean collection of tables which represent different entities, and they contain attributes about those entities. For example, we have employees, we have managers and department. In each of these tables, we have information about that specific entities. And then we also have to define the relationship between those entities or tables, and that is what relational database is. Okay? Is this clear? Yeah, and in like another stage, you may also want to find the, let's say, department name of Manisha Shah. Then you will need like to access employee, manager, and department, because first in the employee table, okay, you have the manager ID, right? And then manager ID is the field that is linking the employee table to the manager table, right? Because this is the common field between them. It's a unique identifier in the manager table, which is the foreign key in the other one. I will explain more about primary keys and foreign keys later. And okay, so from here, you can find, if you just focus on the employee and manager table, you can find what is the name of the manager of Manisha Shah and what is the department ID, right? But you may not, let's say, for example, if the department ID is ECS, so you can find out Manisha Shah is working in ECS, but you may not know what is ECS name, right? It's, for example, electrical and computer engineering, so that is department name. For that, you will also need to link it to the department table. And here are the database components. What do you think are the main components for the database? So you can cheat from here. But I would like you to also think yourself, and you can think, for example, when you are designing a website or application, right? You need also a database. So these databases are kind of connected to, let's say, an application, yeah? So you enter data, for example, in application when you, let's say, log in or create account, and then that information is stored in the database. So they should be connected, right? So you have that application program, you have the database itself. You also have the database engine. So the database itself is the core part of this database component, where we actually keep the user's data, we keep the metadata, and metadata, if you don't know, is just providing information, extra information, additional information about, for example, the structure of the data itself. And then we have the indexes. We'll also talk about the indexes in like next sessions. And also application metadata, which are, again, extra information, additional information about the application. So these are what we actually put in the central storage of the data, which are the databases. And then we also need a database management system engine, where we have two parts, let's say design tools and runtime tools. Now, in the design tools, we have table creation, form creation, query creation. So why do we need each of these? So for the design tool, this is where the developer is actually working with. Why? Because he or she may wants to, for example, create tables, create reports, like for these kind of things. And then we also have a user that is working or interacting with, let's say, the front end of the application or website, but he or she is actually also somehow using the database. Either he's entering data into the database or he's retrieving some data. For example, you are buying something, so your purchase information may be recorded in the database. And so this is the runtime part, right? So this is the interaction with the user at the runtime. So that is when your actually user is interacting with the system. And use, for example, the form processor, query processors, and etc. And we have a 3 schema architecture. Why do we need it? Because we want to keep these different levels that you see here, and I'm going to explain. We want to keep them separate. Like we have an internal level. At the very lowest level, we have this internal level or physical, let's say, level where it's actually more about like how or where you keep the physical storage of the data, okay? And then at the intermediate level, you have the conceptual level or conceptual schema. That is what you are going to create for your assignment. That is where you learn about ER modeling, data modeling. You learn about how to build ER modeling using the entities and the relationship between entities and so on. So when I was talking about those entities, attributes, and the relationship, those are all about conceptual modeling, okay? So these happen at the conceptual level. And then at the highest level, you have the external level. At this point, this is actually what is the most interesting part for the user, right? This is the part that user has interaction with. And it may have like, the reason that you see like external view 1, 2 to n is because at the same time, the same application may represent different views to different users, right? So you are on, let's say, Amazon website, you are at like a specific view while other users are viewing it differently. This is just the explanation of what I already explained. ANSI and Spark, I just mentioned that what they stand for. So it's American National Standard Institute, and Spark is just a Standard Planning and Requirement Committee. So here is just an example of a conceptual model. So your conceptual model more or less is similar to this. So we have, is it actually visible, or would you like me to more focus on, like zoom in? Zoom in, okay. Is it okay? Okay, so here, let's say it's about an e-commerce website, and this could be a sample, let's say, a schema. And then what you see here are different tables like, for example, suppliers, products, employees, orders, customers, and etc. So you see that these are related. Later we will learn how we find out which ones we have to connect to. Some of them are more obvious. It depends on when you think about the possible queries that a user can search for in a website, then you will realize, okay, I have to connect this to that. And some of them can be like more obvious when you practice more with different examples. So for example, here we have a product table. Just a quick note about what you see in bold are primary keys in each table. Anyone knows what primary key is? Yeah. Yeah, unique identifier for each row. So we see supplier ID is a unique identifier in the supplier table, right? And so it could be primary key. Can we have supplier ID as primary key also in the product table? Because we have a supplier ID in that table too. Yeah.
Will it be a foreign key instead?
Yeah, it will be a foreign key. So foreign key, simply say, is a primary key in another table. So when a primary key in one table appears in other tables, we call it foreign key. And foreign key, in contrast to primary key that cannot be repeated in your table, foreign key can be. Like let's say, for example, back to the example of the employees and departments. So let's say employee ID is a primary key in the employee table, right? And then you also have another table for the department, right? So you have department table here, and you have department ID, department name, and so on. So for example, we have, let's say, department ID is yes, or business, or something else. And then in the employee table, we have employee ID, employee name, and let's say also department ID. Okay, this is just an example. And here we have employee ID, for example, 1, 2, 3, 4, 5, 6, etc. And let's say this is in BCS, this is also in BCS, and this is in business. This is Mona, Alex, so on. So what I would like to explain here is what is the, okay, a question. What is the primary key here in the employee table? Employee ID, because it can be used as a unique identifier here. So we cannot have two employees with the same ID. The same applies to a student number, right? We cannot have two students with the same student number. We cannot have two courses with the same ID. And how about department? Department ID, right? Department ID is the primary key there. So we said that, okay, department ID, when it appears in the employee table, here it is not primary key anymore. Instead, it is a foreign key, right? And the difference between primary key and foreign key is that foreign key can be repeated, right? So in this table, in the employee table, department ID cannot serve as a primary key. Why? Because two employees can work in the same department, right? For example, the same course can be taken by different students. On the other hand, one student can take multiple courses. So it is important to work about these type of relationships later, because that will define the relationship between your tables in your database. Yeah. Which row deleted? In the employee table?
Like for example, Mona gets deleted, 1, 2, 3 is deleted. Can that be reused later, that employee ID, or never?
So I delete this row.
Yeah.
Okay.
Can we reuse that employee ID later, the 1, 2, 3?
We may not need that in case of the ID, because, okay, it depends. If you're entering something new to the database, and in the current state of your database, it doesn't exist, so yeah, you can, as long as it's unique. Yeah. And you can also, sometimes you can also think about, I'm trying also to answer the questions that I had in the previous, the other section of this class. So there was also, you may have, for example, the course name. So someone asked me, how about choosing the course name as the primary key? Okay, because course name also is unique. We don't have two courses with the exact same name. So if that is the case in a scenario or in a use case, it is okay, but it's not recommended. Most of the time, at least I suggest you to pick a numerical like unique ID as a unique identifier for your primary key, instead of, for example, using emails or using the names, even if they are unique now. There might be later, for example, let's say you have a class with, for example, 20 students, and your database is very small, and you know that no student name is repeated later. Even if in that case, I would highly recommend to not use the name as the unique identifier, because later you may enter another student in your database with the same name, right? For example, my database right now may have Mona, Alex, Angel, etc. And you say, okay, all these names are unique, so I use that name as a unique identifier. So what about later if you enter another Mona into the database? So always keep in mind, it's better to define something like product ID or number, or for example, if it already exists in your database, such numerical data, that's fine. Like for example, course code. If the course code already exists, you won't need to generate that. But if not, you may need like a numerical ID. Also, in terms of the database performance, it's always more efficient to keep the numerical data instead of the text, right? It needs less space.
Can multiple columns be the primary key? Like, let's say we have like, you can have ECS 1000, but also like ADMS 1000. Can we have like the department and that's allowed?
Yes, we can, and we will learn about that. Yeah, so 2 columns or even more together can form a primary key, and we will also learn that. Yeah.
Generally for tables, I don't remember can we have like multiple primary keys? Like
It's I think the same question as your friend mentioned. So we can have multiple columns that they together serve as a unique identifier. It doesn't make sense to have like 2 different primary keys, because the goal of having a primary key is just to have a unique identifier, right? When we want to access the data. But we can have like sometimes if we have a table sometimes that one column alone doesn't uniquely identify rows, but a combination of 2 columns may do that. For example, we may have, let's say, EECS, and then the numbers, and then combination of these 2 columns may together serve as a unique identifier. Because, for example, we may have, let's say, EECS 1015, right? And business 1015. And then it may, let's say this part could be repeated, hypothetically. I know that this is not the case with York University, but sometimes it is. So sometimes if that is the case, and we will see some examples, then 2 or even more columns can form a primary key. And thank God. And I know it gets very boring to, like, I remember I had this issue when I was in class. I never could like keep like focusing on like the instructor, what he or she was saying more than like a few minutes. I was like, oh my God, I'm lost. So I try my best to engage you. I know that it's not 100%, but as long as you are like, in general, you are not very bored in my class, I would be very happy. And let me know when you are, then we can do a lot of things. I can give you like a 2 minutes break to just get refreshed. We can plan for some games, a lot of things we can do. So internal level, or the physical schema that I was talking about, this is describing the physical storage or structure of the database, how the data is stored, for example, the access path to the database, so this kind of information. And you remember when I was talking about the 3 schema architecture, ANSI, right? and I said that we have like 3 different levels, internal level at the very like lowest level, and then conceptual level, and at the highest level we have the external level and external views that is different for different users. That part, the goal for that kind of a structure is just to keep these levels separate from each other. And why do we need to have that? Why do we need to keep them independent? Yeah.
Is it so if we need to like later on we need to change something, be it like in the exterior level, like we need to change how it looks to the customer, or if we need to change like the data in our in the interior schema, we can change those without having to change the other levels.
Exactly. So we want to like keep them independent, so that if you're going to change something at the very internal level, you don't want it to also do the same change at the conceptual level. So we have this logical data independence and physical data independence. So logical data independence is between these two. So we have we had these 3 levels. So this was the external, this was the conceptual, and this was the internal level. And then you had the database here. So what is just explaining here is simply saying that we want to keep them different. And this is referring to the physical independence. And physical independence means that changes in the internal won't need changes in the conceptual, and the logical independence means that changing in the conceptual doesn't need to change things in the external view that are shown to the users. So if you want to, for example, add new data or feature to the conceptual level, we don't have to do the same change, or it doesn't affect the external view that the user is seeing. So this is just I explained. DBMS, we already mentioned, DBMS is just like a storage for databases. We have, for example, Microsoft SQL Server, we have MySQL, we have IBM DB2, so several different database management systems. I personally like MySQL. I used to like MySQL a lot because it's open source and it's easy. It had a very good community, like support community, if you had any issues. But for my previous course, I had to use Microsoft SQL Server, which was also great. The downside was that it is not free, and it is also not installed on the lab computers at York University. So I have to figure out a way either to use PostGRE, which they are using, or I also prepared a guide for you to download and install SQL Server, both locally or if you prefer to work on the cloud. I also give you that option. So it depends on you. And so I will share all this information with you by the end of this week. So these are the functions of database management systems. So I'm going to skip this. We already talked about DBMS. So database development process. This is actually what you're going to do in your assignment 1-2 in pieces. So assignment 1 is just some part of database development, which is the conceptual level and ER modeling. And then your second assignment is the SQL implementation, database implementation using the SQL and query languages, using queries for, using SQL to query your database. And so I'm going to explain all the steps that are required, like at higher level, what steps are required when you want to implement a database, design and implement a database. So first of all, we have this initial study or requirements here. As you see, we have database requirements. So this is the very first stage where you collect information about, for example, if you want to develop an application and you want the database for that application, then you have to always start with this step. And I think the two steps are very important, because that gives you idea about later when you want to design your data, your database, and you want to do data modeling, you know what entities you need, you know what attributes you need. So these are all about what you do at this stage. And go back here. For your project, you need to analyze the company situation. Let's say you are assigned to case one, and case one, let's say, is a car rental. And I provided the link to a car rental. You go to the website, you see what are the functionalities there, and you also have to think about the company situation, but also what problems they have, and for example, what is the overall objective of the company, and then defining a scope and boundaries. I'm going to explain what is the difference. This is going to, you are going to use this in your first report. So for your final project, there are several stages. Because I didn't want you to get overwhelmed at the end of the semester. So it's in different stages. So you have a project proposal. At this report, which is just one-page report, it's very easy. This is where you explain everything. So for example, this is our project. For example, we are assigned to case one, which is, for example, car rental, and this is the objectives of the business. This is the current situation, and then you have to define the boundaries and scope. Who knows what is the difference between boundaries and scope? Or even if you just know any of them, you can explain. Yeah.
Boundaries is like the limit of how far you can go. Scope is like how far you want to actually try to get to, like what your vision is, sort of, like how far you want to go.
How far you want to go? That's a scope or boundaries.
That's scope.
Scope, exactly. So that is defined by you. And what are boundaries? Yeah. Oh, yeah, you say. Yeah, sorry.
There some limits you set on yourself, or some obstacles you find along the way.
Yeah, so they are mostly limitations that you encounter that is, let's say, out of your control. Let's say, for example, if you have a budget limit in a project, or if you have a time limitation. So those are the boundaries. You can't do anything about them. But there is also a scope that you define. So you say that, okay, I want to include this and this and this, but I want to exclude those things. So that will be the scope of your project. I would suggest you for your final project, keep it simple but correct. So don't try to overwhelm yourself with lots of entities and relationships and get lost in between. So try to start with something simple, and then if you wanted to add something later, you can do. And so that will be the scope of your project. And usually, the boundaries that we have, the time limitation, will also affect the scope, right? Because if we don't have enough time, we may want to make it more simple. This is the difference that I was just explaining. And here are the steps in the development of the database. So database requirement, the first stage, you have it in your project proposal. Then we have database modeling, where we learn about how to define entities, attributes, relationships, how to create ER models. So that part is database modeling, which is in your assignment 1. But also for your group project, back to this one. Okay. Report B, and then final submission and presentation. So the goal of the 2 reports, if I didn't mention before, or if you were absent, is just because to help you get some feedback for your project so that you know if you are on the right path. So the project report A is, for example, let's say before the midterm, and then project report B is later, and then final submission is almost close to the end of the semester with your presentation. So back to the steps in the development of the database, we have also database modeling, which is the logical modeling. So after the conceptual modeling, which is that ER models, we have the logical modeling, which is just translating them into, like, now you say, okay, these are my tables, these are my attributes of the features of my tables or attributes of the tables. These are how we want to link the tables together. So that's the logical modeling. And then database implementation. That is when you actually write those SQL queries to implement your database. You use the DBMS for that. And at the same time, we have developed like this front-end application because it should also be connected to the application, right? And so this step is simultaneously so that we can adjust if there is anything, like if there is any issue on the application side or at the database part. And then we check everything in the deployment. And finally, database use and administration. So we always need database administration part because even for a database that is already developed, so as you see, there are jobs for database administrator, right? They have already created the databases and they have everything, but they need someone to optimize the data, to keep track of everything, to like be able to recover and maintain the database. So those are also very important. So these are just every step that I already explained, but these are just in more slides. So we talked about database requirement. We talked about conceptual model and logical modeling. What is the difference? I just explained. What is the conceptual modeling? Yeah.
It's like just a rough drawing,
Mm-hmm.
and then the logical one would be all the tables written out.
Yeah, more or less, yeah, he's right. So you have at the conceptual level, you just draw everything, your ER model, you say, okay, we have these are the main components, and this is conceptual, right? And then for the logical, you say, okay, now I'm going to have these tables, so you are converting all of those to tables and relationships and attributes for the tables. So logical design, translate that conceptual level, that ER model that you just created, and translate it into internal model for selected DBMS. And we'll see about like design of tables, indexes, views. These are all covered in this course. This is example for logical database model. So at this stage, you know this is converted, your ER model is converted to relational schema. So you know what are your tables, what are, for example, primary keys, what are the attributes. And physical design, I already explained at the very lowest level, which we had the internal level. We need this physical design that is just for physical storage of the data, or for example, access path to your database. There are something that you have to consider. So I'm going to try not to talk more because I feel like you're sleepy. But yeah, I promise these are the last few slides. But we have to, I have to go through this. And then we try to be more interactive with ER modeling and SQL and everything, so you wake up later. For the design, you always have to consider these factors, which are performance, security, backup, and recovery. So, for example, about performance, what do we mean? Yeah.
How quickly you retrieve data.
Yeah, it could be about trying to speed up the process, right? If you are working also as database administrator, one of also your role is to optimize the database. And there are many great ways to do that. I was once working in a company I still am very happy when I think about it, because it was just a one line that I don't know, even if I found it finally Stack Overflow when I asked this question, but just one line of code in one of the main files of the database improved their the speed of application a lot. So it was they were a company for they wrote these applications for the fuel card and like petrol something. I forgot the name, how to translate that in English. And then the good thing was that it was with I think SQLite and InnoDB, and it's amazing. Like with just when you see that you can, for example, they had this problem that their application on the application side, it was super slow. It became super slow, and they couldn't figure out what they have to do. But just like a quick adjustment in the database could, like in the configuration files, not in the database itself, could like increase the speed a lot. So we always need also that performance part, which is very important. The security, because we want to protect the data, right? And we want to prevent the data loss. Backup and recovery for sure. We want to have like regular backups and recovery as well. How about integrity? Anyone knows what does that mean? Integrity. Yeah.
No one touched it. It hasn't, the data hasn't been changed by anyone else.
Yep.
I also guess like how long the database can physically last until like it breaks, like if it's a disk.
Yep.
I would say that ensures that the information is not modified nor destroyed and keeps its availability.
Yeah, it's about, as your friend said earlier, about the consistency and accuracy of the data. Yeah. And the company standards, it's about, like for any company or organization, they have some guidelines. So you have to also want to adhere to those policies and guidelines. And then concurrency control, because you may want to you have to be able to control the simultaneous access to the database, right? So that is what concurrency control is about. Here's just a sample screenshot of the database implementation, just to give you some idea of what we are talking about. And you don't need to know how to create tables right now. This is just a screenshot to better visualize it. So for next session, I would like you to read the required book chapters. I'm going to update the course schedule. I know that if you click on the course schedule on eClass right now, there is no schedule there. So I'm going back to